Yes, sir.
Okay. So in last class we have I have explained about what is meant by the field of line charge. Okay. So and then we have seen uh, that is the full construction diagram. Okay. So today we will go with how it can be derived. Okay, how it can be derived. Please see, this is the condition. This is one wire. You can imagine how the wire. So in a lab, you have seen some connecting wires, or else in home itself, you can see some connecting wires. Maybe it is a thick or thin or somewhat moderate thickness. Okay, so based on that, what is the length and what is the portion we have defined in this geometry, and based on this formula only, we are going to derive. So E is equal to Q divided. It is for the single point charge. You can see this is for the single point charge. Q divided by 4 pi epsilon r square. Okay, 4 pi epsilon r square. So by using this formula, okay, it is what? It is a Coulomb's law. So normally in Coulomb's law, how we can express it up? The force experienced by the two charge is directly proportional to the product of the charge and inversely proportional to square of distance between them. Correct. But for this differential quotient, you can see red color I have shaded. This part, what is the charge? So it is the line charge dl. Okay, that is rho l into dl. So instead of q, I have put as rho l into dl divided by 4 pi epsilon r square. Okay, so at this point, please see at this point only what is the field component going to generate. So for this to derive,
Sir,
we yeah, please tell.
sir, for these concepts, questions we'll only get like numerical based, right, sir?
Yeah, exactly. You will get a MCQ or some not derivation. Okay, not derivation. So what only I'm not going to derive fully. Okay, it is not useful for you. Just the steps alone I am going to tell, and what are all the important formulas I will tell. Okay, so since you are going to have some objective type of questions, okay, so you not have full derivations. Okay, but you should know the steps. Sometime the intermediate part will be asked in your question. Okay, so what only I'm telling. Okay,
Okay, sir.
Darshan. Yeah. So for that, the DE value is like this, and for the point P, we going to find what is the vertical component and horizontal component. For that, we have multiplied with these two. Okay. So then from the geometry, we have to attain some values. Okay. So actually, your resultant electric field. Okay, the resultant electric field DEX can be given like this for a vertical component. Okay, so that is rho L DL sine theta. Okay, rho L, that is sine theta is for what vertical component? 4 pi epsilon h. So after applying to the geometry, okay, I'm not fully derived. Just to know the formulas alone. Okay, just to know the formula, it is the vertical component. Okay, it is the vertical component. But please see, it is in left hand side, it is DEF. Right hand side, you can see it is a DL. But we should express it off in that is full density, that is full element. Okay, full element. Then I want the full term. Then integrate on both the side. I'm not going to integrate fully. Okay, it will take time. Okay, integrate on both sides with a limit of, please see, with a limit of, please see in the previous slide, the limit either alpha 1. So this point to this point or this point to this point. Anyway, you can take. I'm going to alpha 1 to pi minus alpha 2. Okay, which means that I'm going to take the other part. This is nothing but a pi minus alpha 2. It is the alpha. So why taken like this means you can see this is up to this point. You can see this is pi minus alpha 2, where this is alpha 1. Okay, this part. Here you can see alpha 2. Why we have taken like this means this is I have drawn the two differential line. Actually, the field will be across like this. It will be like a one sphere. Okay, it is one sphere. So what only our our boundary conditions will be like that. Okay, so it will be like this alpha 1 to 5 minus alpha 2. When you have the free time, you can integrate and see. Okay, so then you will get Ex value as rho L divided by 4 pi epsilon H into cos alpha 1 plus cos alpha 2 if you integrate this step. Similarly, we have to find the vertical component also, sorry, horizontal component also. So if you derive with the same limit, you will get like Ey is equal to rho L 4 pi epsilon H into sine alpha 2 minus sine alpha 1. Okay, I have directly given the resultant equations. Okay, just you for your understanding. So now I am going to put a two conditions. Okay, now I am going to put the two condition. If the point P2, okay, please see the diagram. If the point P2 is a bisector of the line alpha 1 and alpha 2 equal to alpha. I am saying that if the point is perfectly bisect with this line, then how this triangle become? It is a equilateral triangle. I can say that alpha 1 and alpha 2 becomes equal. Okay, alpha 1 and alpha 2 becomes equal. So please put alpha 1 and alpha 2 is equal. Okay, equal. If it is equal this point, what happened? It becomes a twice of cos alpha 1. If you simplify 2, here 2 goes. So this becomes Ex alone, you will get rho L divided by 2 pi epsilon H, where Ey. So if I put alpha, alpha, these two terms are get cancelled. Ey not comes. Okay, that is case 1. Okay, the case 1 is like this. If the point P, okay, if the point P is a bisector of the line, is at bisector of a line, okay, bisector of a line, then alpha 1 equal to alpha 2, I am assuming it as alpha. So then Ex is equal to rho L divided by 2 pi epsilon H cos alpha, where Ey becomes 0. Okay, case 2. Let me see the case 2. If the line is infinitely long, if the you can imagine what is the condition you will give. So please go to the condition. If this line is very lengthier, okay, very lengthier, then what happens? Okay, so then the same condition will attain. Okay, the same condition will be attained. So either alpha 1 is equal to 0 or alpha 2 becomes 0. That is, you can please imagine, just I am expanding, stretching the line. Then this triangle becomes in same line. Okay, not be tapered. Okay, your point of field will be on the axis. Okay, it on the axis. So then I will put alpha 1 and alpha 2 equal to 0. That is alpha 1 and alpha 2 becomes 0. So if alpha 1 equal to 0, what happens? So cos 0 plus cos. is 1 plus 1, it is 2. So you will get Ex is equal to OL divided by 2 pi epsilon H, where Ey sin 0 minus sin 0 already 0, 0, I think 0. So here also is the same. Please see the condition. If the point P is bisect, means the cos alpha is coming. If alpha is equal to 95 volt, what happened? This term also advanced. Ex also advanced. But I am not putting alpha is equal to 0. It is the condition I am giving. So at this condition, I will get only Es component, not Ey component. So in both the case, like the line is infinitely long and bisector, both the case Ey is equal to 0. Okay, Ey is equal to 0. Okay, so this is the concept behind to this thing. So let me go with the next one. So these are the applications. First of all, you should understand that these are the applications. So through these applications only we are deriving these concepts. Okay. Let me go ahead with the next one called as the electric field intensity. Electric field intensity. Sometimes I'm telling electric field intensity. Field intensity. In some cases, I will tell like E field. Both are same. Okay, don't get confused. Electric field intensity and E field. And we're going to calculate the potential. Okay, we're going to calculate the potential at any point. Okay, at any point, at any point, due to a line, due to a charged circular disk. Charged circular disk. Okay, so suppose I'm considering a charged circular disk. Okay, it is one circular disk. Okay, this is my circular disk. So at the mid of this point, okay, so I will get some concentric field. Okay, so this is the full boundary. Let us consider the radii of this is nothing but capital R. So then what is my field at the point P? This is the field at the point P. Okay, so for this point, we're going to determine the what is the electric field and what is the potential. Okay, just remember the formulas alone. Okay, this is the geometry. So from the centric point of the circular disk, this is a O of a H at the point P. So the field will be distributed over to her. Okay, the field is distributed over to this surface of the circular disk like this. It will be like this. So then, what is the radial distance of this is nothing but R, and inner concentric ring. If you want, you can put it is a. I have put just the maximum radial distance of R alone. The thickness of this radial thing is nothing but dr. Okay, and what is the field at the point? So this is the field. Okay, so I am drawing a line towards to the point P. Okay, this is the point P. So then of a distance d. Okay, of a distance slant height of distance d, which has inclined of angle theta. Okay, of angle theta. So then what is your electric field? So please see here, there is a two components there. One is the height. It is nothing but the height or altitude from the point O to P, and where D is nothing but the slant height, where capital R is nothing but the radial distance. Okay, radial distance. Then the same condition, how we have done that procedure, the same way here also we have to look into the what is the vertical field and horizontal field. But please see, here only focused on the vertical component alone, not horizontal component. If you want horizontal component means, please see, just you itself, man calculation, you itself know whether in this case the that is magnetic, that is sorry, horizontal component comes or not. Definitely not. Why? The that is your circular disc. Okay, this is on where it is on the ground. Okay, on this plane, on this plane, this is nothing but your horizontal. So whenever the object, okay, this is the object we are placing over to the horizontal plane or the ground plane, it is overlap to that plane or coincide with that plane. In similar, previously the wire is there, that is also coincide on with the ground. Okay, so if such a conditions comes, your horizontal component get vanished. Only vertical component alone. So just to remember the formula for this, it is nothing but electric field is equal to rho s divided by 2 epsilon into 1 minus h divided by root of h square plus r square. Okay, this is your electric field formula. This is your electric field formula. Similarly, after finding this thing, we have to find the electric potential. The electric potential. Actually, electric potential is one of the scalar quantity. Okay, the one is a scalar quantity. So we already studied what is the formula for it. That is the potential V is equal to minus integral of d to 0 E into dx. Okay, so when we say about the statement about the electric potential, at that time I have shown the definitions equation also like this. So then the formula for this is nothing but V is equal to rho s divided by 2 epsilon. Okay, rho s divided by 2 epsilon. The whole root of, okay, the whole root of h square plus r square minus h. Okay, the potential for this is nothing but V is equal to rho s divided by 2 epsilon into root of h square plus r square minus h. Okay, so this is your um, that is this condition, for this condition, like electric field intensity and potential at any point due to the charged circular plate. So the same case we can define it for the infinite case also. It is for the some finite case. Okay, it is for the some finite case. So then for infinite case, how it come? Okay, that is electric field, the electric field intensity and the potential. The electric field intensity and the potential at any point. Okay, the same statement at any point, at any point due to infinite plane sheet, due to infinite plane sheet of charge. infinite plane sheet of charge. Okay, the same thing. Okay, don't get confused. The same thing. Previously, we not have the word like infinite. Okay, we have only electric field intensity and potential at any point due to the circular plate. Instead of the normal plate sheet of the charge, there have the circular charge sheet. Okay, here you have the infinite plane sheet. Okay, so suppose I am consider this is one of the sheet. Okay, this is one of the sheet. Okay, this is one of the sheet has the surface charge density as rho 2, rho s, and at the point, infinite point P, what is the field intensity and the potential we are going to calculate. Okay, by using the Coulomb's law expression, that is electric field for this case is nothing but rho s divided by 2 epsilon. Okay, rho divided by rho s divided by 2 epsilon. Similarly, the potential equation will come like this. V is equal to rho s divided by 2 epsilon, the whole root of h square plus r square. So this is the difference of the previous case and this case. You can see previous case electric field, it is rho s divided by 2 epsilon into 1 minus h divided by whole square of whole square root of h square plus r square, where v is equal to this thing. But here we have substituted the value of this electric and magnetic field respectively. Okay, so these are the applications of the Gauss law, and it also application for the Coulomb's law. Okay, let me see how the electric field intensity can be calculated for the two infinitely conducting plane. For two conducting plane. So I hope everyone that is seen the capacitance image. Inside the capacitance image, you have the two parallel plates will be there. So one plate is positively polarized and the other one plate is the negatively polarized. Okay, so for single plate, okay, please see in the previous thing. And in the previous case, for a single plate at infinitely plane sheet of the charge is given, E is equal to rho divided by 2 epsilon. Okay, so let me go ahead with this thing. That is, two things are there. That is electric field intensity between the infinitely conducting plate. Where I write the statement, the electric field intensity between the two infinitely conducting planes. Okay, so let me go through this thing. Previously, only one sheet alone there, but here there is a two sheets are there, but each one are parallel to each other. Okay, parallel to each other. If suppose I am say for this conducting sheet rho s is the surface charge, here also rho s is the surface charge, then what is the distance between these two? It is nothing but capital D, and for the point P only, the field intensity and the field under the then what the potential we are going to calculate. Okay, so for single sheet, what is the electric field? We already found in the previous derivation, that is sigma divided by epsilon. Sigma divided by the epsilon. Similarly, so for single sheet, what is the value? It is nothing but 2 epsilon. Sigma divided by 2 epsilon. Okay, please see the previous one. Okay, rho s we have defined, it is for the surface. In order to know, I have given as the sigma. Similarly, for this also, what is the electric field? It is nothing but rho divided by 2 epsilon. Just adding these two. Okay, so that is the total electric field is nothing but, suppose I am putting this is E1 and this is E2. So then total electric field is nothing but E1 and the E2. So that is sigma divided by 2 epsilon. 2 epsilon. Just I will rub it and I will write so that it will be clear. Okay. So when I'm adding this to critical frequency, then I will get a sigma divided by 2 epsilon less sigma divided by 2 epsilon. Then the value is that is twice of sigma divided by 2 epsilon. 2 get cancelled. The value for the electric field is nothing but sigma by epsilon. Okay, for the two infinitely conducting plane. Okay, for a two infinitely conducting plane. So this is the conditions. Okay, so I hope you have understood this thing. So this is nothing but your electric field intensity and the and then what it is the charge density. So like this only we have to be evaluated. Sometime in the problem they will give the values for each of any one term and they will ask the unknown variables. Okay. So this is possible. Uh, okay. So this through this we have to be practice some problems. Let me go with the one problem alone. I will quickly solve that small problem. It is based on the Coulomb's law. This type of problems you may come up with your UG level also. Anyway, we will quickly go ahead with this problem. And like that, some problems may be asked. Okay. Problem. Okay. So please make a note. That is a two small identical conducting sphere. Two small identical conducting sphere have a charges of have a charges of -1 nanocoulomb and 2 nanocoulomb respectively. If they are brought in a contact, if they are brought in a contact and then separated by 4 centimeters, what is the force between them? What is the force between them? So in a given problem, please see the question is like this. There is a two small identical concentric sphere. Okay. So that is two identical. So that means what the radius will be the same for the two sphere. So one has the 1 nanocoulomb and the other one has the +2 nanocoulomb. So it is negatively charged and it is a positively charged, which is separated by a distance of 4 centimeter. That is 4 into 10 to the power -2 meter. So we have to obtain the what is the force expression. Okay, so if they ask like this, what you have to do? We have to. They have mentioned that is a two charges are equally charged and brought in a contact and separated. So then we should know what is the resultant charge across this point. Q is equal to Q1 by Q2 4 divided by 2. Okay, summing up and you have to do it. So minus 1 plus 2 into 10 to the nano means 10 to the power minus 9 whole divided by 2. So if you solve it, you will get 0.5 into 10 to the power minus 9 coulomb. So we know the force. Actually, what is the thing asked? They asked the force only. Okay, just substitute the force equation. That is force F is equal to Q1 Q2 divided by 4 pi epsilon naught r square. So substitute the value, that is zero point 0.5 into 10 to the power minus 9. So both charge are equal. So it is the whole square whole divided by 4 pi epsilon naught into 8 to the 8.54 8.854 into 10 to the power minus 12 into r square is there. So r square, that is 10 to the power 4 into 10 to the power minus 2 is there. That is 4 into 10 to the power minus 4. So you have to solve this thing. Okay, just you can solve. Okay, and just ensure the result. Now the time is not there, so I am just quickly putting. That is 5.625 micro. Okay, this you will get. So this type of problems they may ask. Similarly, sometimes they will that is the your charges may